Folks, for many years, VMware and our partners have endeavored to realize a goal that was originally set forth by our CEO, Pat Gelsinger. That is to virtualize every application and database in existence. A lofty goal. Well, welcome to this introduction of Project Capstone, in which the long-held aspiration of being able to say confidently that every application, every database is a candidate for virtualized infrastructure, that 100% virtualization is truly a reality. So it's my honor to introduce you to the three historic companies and their executive representation whose collaboration has made it possible to state with confidence that no matter how critical, regardless of the resource requirements or demands, that, again, every application and database is truly a candidate to be virtualized. So what we're going to talk about here today, first of all, just a little bit of introduction from myself, and then my vice president and friend, Mark Lohmeyer, is going to do an overall initial presentation of vSphere 6 and its capabilities and how it relates to this particular project. And then Randy Meyer, vice president of business critical servers and mission critical servers from HP, is going to talk about the Superdome X, this incredible project to have ported the Superdome to Xeon, and we'll see the incredible power that's part of this server technology. Then Mike Kuhn from IBM, the VP of FlashSystem, is going to give us an overall perspective and understanding of how the flash system actually is an intrinsic part of this project as well. And then from performance engineering, Todd Muirhead is going to discuss the test results, the architecture, as well as future tests that we're also going to have. And then we'll do some Q&A at the end. So just a little bit of history of this. vSphere 4 was when there really was an introduction for viability for business critical applications and databases. It really wasn't until then. We had really reached a point where we could get 95% of the I/O that a respective physical system could get, and we could go up to 8 virtual CPUs. So we had a legitimate introduction to true business critical applications. vSphere 5, we introduced 64 virtual CPUs, and we had tremendous capabilities, really at the point where we could say 99+% virtualization. It's in vSphere 6 where it really matters. In fact, we have a panel later on this week that is going to be based purely on this concept of no application left behind. The applications and databases and their ability to perform are really limited only by the hardware that is part of that physical infrastructure. Now, the collaboration between HP and IBM and VMware is really what is making this possible to state that 100% of applications and databases can be virtualized. So, and of course, we've got a lot more tests and a lot more architectures to build and to determine exactly how capable this particular stack is. But we really are at a point right now where the discussion is over. Everything can be virtualized. So the physical components of Project Capstone, of course, include vSphere 6, the Superdome X, which you see, and the IBM FlashSystem. So it is my pleasure to introduce you to my vice president, the vice president of products in the Cloud Platform Business Unit, Mark Lohmeyer.
All right. So thanks, Don, and it's great to be here with all of you today. I'm really looking forward to the next hour and sharing with you some of the work that VMware has been doing with our partners, HP and IBM. I think it's really exciting, and we're looking forward to sharing it with you. You know, before we dive into some of the details, I want to just set a little bit of context about how VMware thinks about our strategy and then how this work really fits naturally within that. And if you look at how we describe our strategy, it's really around how do we enable one cloud for any application and any device for our customers. And you know, if you look at the key of this or the heart of this, it's really all about the application, right? That's what powers the business. And the challenge for IT, of course, is to enable a broad range of applications, from traditional applications to new modern cloud-native applications. And so VMware's goal is really to deliver the software-defined data center that helps make that possible, right? Really enable IT to deliver these applications as a service rapidly, agilely, with agility, with the right SLAs, and very cost-effectively. And at the core of that, although the software-defined data center spans compute, network, storage, and management, really at the foundation of that is vSphere, right? And so that's what I'm going to focus on a little bit more today, and was really the focus of this collaboration. So, when we say any application, what does VMware really mean? And if we look at most of our customers today, they've virtualized anywhere from 60, 70, maybe some of the more advanced ones have virtualized 80% of their applications. Our goal is to really deliver a platform that allows our customers to virtualize all their applications, 100% of the applications in their data center. And if you look at sort of where you see applications tend to be less virtualized, it's really at the ends of the spectrum, right? Scale-up applications, the most mission-critical applications at one end, and at the other end, scale-out applications, things like Hadoop running across thousands or tens of thousands of hosts. And so we want to deliver a platform that enables IT to virtualize 100% of the apps, all the way up to the most mission-critical business applications for our customers. So we just recently released vSphere 6.0 in Q1. This is a great release we think is really going to, for the first time, make it possible to virtualize literally 100% of the applications in the data center. Just touching upon this briefly, significant and meaningful improvements in terms of scale and performance of the platform, right? So across literally every dimension that you could look at in terms of number of nodes in a cluster, amount of resources in a physical server that you can take advantage of, the size of the virtual machines, we've delivered 2 to 4x improvements in scale and performance across all of those. Also as important is not only just size and scale, but if you think about IT being agile and responding to the business, you have to be fast, right? And so with this new instant clone capability, we can literally provision new VMs on a sub-second basis, right? Pretty amazing. So meaningful improvements in scale and performance. And then, of course, second is availability. Again, if you think about business-critical apps driving millions, potentially billions of dollars of revenue for our customers, availability is fundamental. And so with 6.0, we removed all the remaining boundaries on vMotion. So you can now do a vMotion of an application across vCenters, across virtual switches, and even across long distances, up to 100 milliseconds of latency. So put all those things together, you can now literally do a live migration of a virtual machine and the app inside of it from New York to London, respecting all of the vMotion guarantees. Pretty amazing stuff. And then just sort of moving along, again, as our customers strive to get 100% virtualized, we see these environments becoming very, very large. And so making it simple to manage these environments, ensuring consistency with things like content library, where you can share templates and ISOs and scripts, is very important in these larger environments, as well as making sure the whole environment is very responsive. And then finally, really enabling choice for our customers. So looking at things like OpenStack, enabling the developers to take advantage of the OpenStack APIs while still giving IT ops the ability to run on top of the infrastructure they know and love. And then, of course, today we had a number of very exciting announcements around how we're bringing containers as a first-class citizen on top of the vSphere platform, again, giving choice to our customers. So, we're really excited about this release. Just a couple interesting data points. We expect this to be one of the most rapidly adopted releases of vSphere ever. A little survey we did showed that up to 91% of our customers intend to upgrade to 6.0 over the next year. And then actually probably more interesting is since we shipped 6.0, we've had over 30% have already moved to it within their environment. And of that, 20% are using it as their primary platform, right? So that's a very fast adoption for any release of vSphere that we're really excited about. And again, it's being driven by these innovations. So now back to mission-critical applications and really the focus of today. If you look at our customers, these are fundamentally the applications that are driving their business, right? This is what they depend upon. It's what they use to engage their customers. It's what they use to empower their employees. And what we really want to do as a software platform, an infrastructure software platform, is enable those applications to take advantage of all the new great innovations that are happening in the hardware, right, in the server hardware and the storage hardware, and really unlock that value to the application. And so with 6.0, we made meaningful improvements across all these dimensions. I just focus on the bottom there. We talk about a monster VM, right? But with support for 128 virtual CPUs and 4 terabytes of RAM per VM, that's definitely a monster VM, right? And while not every application needs that that scale and that performance and that capacity, it's nice to know that we can support that without breaking a sweat. So we're really excited about those capabilities. And really, those are at the core of a lot of what we're going to be talking about today. So, finally, Project Capstone. And, when Don said we had an opportunity to talk about this with all of you, I was really excited to be able to do this along with our partners from HP and IBM. We're really excited about this collaborative effort where we said, hey, what could happen if we basically took the most advanced technologies from VMware with vSphere 6.0, the most advanced technology from HP and their server division, and the most advanced technologies from IBM storage, and put them together and said, what's possible if you could run an Oracle database, on top of this combination of technologies? And so I'm really looking forward to, sharing that with you today. And I hope at the end you'll see that hopefully VMware is really living up to our commitment or our promise to enable our customers to virtualize 100% of their applications, so no application left behind going forward. So with that, I am pleased to introduce Randy Meyer. Randy is the Vice President and General Manager of HP's Mission Critical Server Division, which includes the entire portfolio of HP's Mission Critical Server products, from HPUX to nonstop computing to scale up Mission Critical x86 servers. And really pleased to be with you here today and walk us through what we're doing together.
Whoa!
Oh,
got it?
There you go.
Thank you for having me. Oh, look, that's me. It is great to be here and to be able to talk about some of the exciting things that are going on. As Mark said, the business I run boots up around workloads. It thinks about not servers or not storage or not networking. It thinks about, I'm trying to take a payment. I'm trying to send an invoice. I'm trying to bill somebody. I'm trying to manage a telecommunications network. Trying to take an order so my manufacturing plant knows what to build. The interesting part about that is, as everybody's carrying a device, everybody's carrying tablets, there's kiosks everywhere, you just expect it to work all the time. You expect the availability to be there. That's why all the vMotion things are so exciting in terms of driving the capability to have online all the time. It's also the case that you expect it to perform all the time, and as it scales up, you've got to handle whether it's more transactions, larger data sets, more users. Those things have to happen seamlessly, or the user gets frustrated. So if you think about this, the biggest workloads on the planet to some extent have kind of been stuck. They've been stuck in older environments because people say, I'd love to get the advantages of moving those into a standard Linux-based virtualized environment, but I can't get the availability. I can't get the scale. I can't get a big enough environment to run that because I can't break it apart. It doesn't shard well. It doesn't scale out well. That's what's changing now. So you start to think about this, whether it's in analytics, where you're doing real-time predictive analytics of parts failing for airlines, whether it's processing insurance claims, all those things, now you can bring those into large-scale real-time environments and kind of transform businesses. So you take this mission-critical foundation that we've known for years and years how to build in big systems, large-scale performance, massive scale in memory, massive scale in processing, massive scale in I/O. Drive the reliability in there. One of the things that makes people crazy in this world is you say, oh gosh, how do I manage my firmware? How do I deal with things where I get low-level errors that I don't want to pass up the operating system? Part of that is taking the intellectual property that we've built up for years and years in the Unix environment and the Tandem environment, saying, how do I apply that today in the Linux environment and allow people to get the benefit of that as you go and virtualize all these workloads? And you've got to do it cost effectively. You've got to drive down the cost. And that's not just the hardware. It's the software investments, storage, everything else. You need high performance, low cost, large scale. And then the magic of virtualization lets you do things like add the resources on the fly, like move from a production system to a DR system while things are running, because that's what it takes to deliver these large-scale environments. You just can't take these big database applications offline. Think about the banking world. Think about the manufacturing world. It's running 7 by 24. There's not time in there to go rebuild things. So it's this idea of you've got to build the whole solution outward from the application in, thinking about quality of service all the way along. It really is a sense of server, storage, networking, integration. So first of all, we took our existing Superdome and migrated that to the Xeon family, created Superdome X. 16 sockets, 240 cores, 12 terabytes of memory today, going to 24 real soon, in a single data set. By the way, you can partition that if you want. If you've got smaller workloads, want 2/8, we can do that. Lots of flexibility in and around that, but massive multi-tenancy workloads that are there. Then you bring in all the firmware, all the software knowledge about how to make that resilient that we learned from our Unix environments, and you bring that into that x86 world. Gives you more reliability, and it reduces downtime by up to 60%. The other thing that you have to do is on the networking and storage side, you've got to drive to 6 nines. You've got to drive to quality of service assurance. You've got to drive the things in and around that so that the whole solution delivers that level of availability. And again, you pair that with virtualized environments, and then you get the flexibility to drive this. So now, large-scale system, you can partition any way you want it, massive quality of service. Now, with V6, we've got the ability to put massive virtual machines and scale those things. It really is, from a customer perspective, you can look at any application that's out there and say, this gives us the flexibility where we thought we couldn't get the quality of service or the reliability or the service level agreement before. Now we can consider that, and it's going to save us money, it's going to be more mainstream in the data center, and it's going to unlock capital to go invest in other sorts of things. So we've seen this already. This is not just a lab project. Not that just lab projects are bad. This is happening in the real world. This is a European insurance company building their next generation ERP system, running kind of a financials-based application to manage all their workload, all their workflow, putting it all in memory. Massive 12 terabyte solution that's here. Database layers in Unix, application layer, a combination of Linux, Windows, Business Warehouse, running across all of that in a virtualized environment. And guess what? Superdome X plus VMware makes this happen for them. It's always on. They've minimized their risk, and they know how to scale this in a way that's going to manage their business growth. This is one of the companies that's growing really, really quickly in terms of capitalizing on a number of trends that are going on in their industry, and they're looking for something that not only solves their problem today, but it saves some cost and makes them more agile going forward. So all the things that we talked about and then Mark just talked about earlier, critical to the success of these guys. So almost every customer I talk to wants to know about, how do I take a big application, move it into this environment, but stay flexible and save cost at the same time? So if you're sitting out there thinking, okay, why does this matter to me? It really is a different thought. If there's large-scale, big database applications that are sitting in your environment that you say, I'd like to save software cost, I'd like to make them more mainstream and more standard in the way they fit into my environment, but I need the SLAs I've become accustomed to over the last decades of running those things. Guess what? This project shows you exactly how you can do that, how you can migrate. We've got customers you can talk to that have already experienced that and understand what to do. Superdome X is a platform that gets you there, but at the end of the day, it's the integrated solution, all of it together, that's going to go deliver on that. So a big thank you to VMware, to IBM for being on stage with us, and for all of you for being here. Go check out our booth out on the show floor. You can actually see a Superdome X that's sitting there, and you can talk to my buddy Ken Pomeranski, the product manager for it, and he can walk you through exactly how we do this and talk about partitions and crossbars and all the cool ways of how you get to these great benefits. So Mark, thanks again for having us.
Great. Thanks, Randy. Thanks. Very, very exciting. So now I'm pleased to introduce Michael Kuhn, who is the VP and Business Unit Leader for enterprise storage solutions, as well as driving their overall strategy around flash storage and the significant investment that IBM is making in that area.
Mark, thank you.
Thank you.
Good afternoon. It's great to be here. This was truly an interesting project, so I want to get into Project Capstone and talk about some of the collaboration and some of the partnership that we did. But I did want to provide just a short context for some of the things that we're doing at IBM, just to sort of give you a perspective of what we see happening across the storage industry. There is a lot of change happening right now across the storage industry, and certainly flash and software-defined is at the center of that change. You don't have to go very far outside into the Solution Center to hear people talk about flash and flash technology. In the same way that it has changed all of us as consumers in the consumer marketplace, starting about 8 years ago with our iPhones and our iPads and our smartphones, it's changing the enterprise data center over the past several years, and it's coming on as fast and as furious as it ever has in the consumer marketplace, and it truly is changing. I've been at IBM for over 30 years now. IBM obviously is a company that's been around for over 100 years of innovation, but I have seen more change in the storage industry over the past 2 years with all the things that are happening around flash memory technology and software defined. It truly is exciting and truly is a transformational element. And certainly in the partnership with VMware and with HP in this particular case on the Capstone project, it really talks about getting to the really, really hard stuff. So when you talk about you can virtualize 80% of your environments, 90%, 99%, you want to get to that last 1%, you're getting to the really hard stuff, right? So this is about doing the really, really hard things. So let me see if I can give you just a little bit of context of what we're doing from a storage business standpoint. I'll get this to work. So, IBM, obviously a very large company, major presence in the storage business as well. So I wanted to sort of highlight a little bit of a perspective from what IBM is doing in the storage industry. Certainly, Mark, you talked about this, you alluded to this. IBM made a major investment around flash memory technology in the storage business. We announced this $1 billion strategic initiative about 2 years ago. It's dramatically transforming the enterprise of the data center, whether it's the traditional data center or the cloud data center. So certainly driving things across the entire data center. We see the world this way from a data storage standpoint. You can't talk about storage without talking about data, right? So from a data storage standpoint, we see there's a hot edge and there's a cold core. Hot edge, cold core. So flash technology is going to be at the hot edge of all your data. People ask me all the time, what % of my data should be on flash, should be on the hot edge? It's hard to give a rule of thumb, but if I had to, it's about 20%. About 20% of the world's data needs to be on the fastest tier of storage, needs to be in that hot edge, and about 80% needs to be in that cold core, which is how you manage these volumes of data. The problem is, data isn't always hot. Sometimes it's hot, sometimes it's cold. It evolves. So you have to have a sort of a software-defined structure, a software-defined capability to be able to manage the data, to have a virtualization technology, to manage all your storage devices underneath it. IBM is also announced earlier this year a second strategic investment in the storage business. It's about a $1 billion investment that we're doing across our software-defined storage ecosystem, and certainly it's about optimizing with our virtualization capabilities. Now, I think from a storage standpoint, we take a very similar approach to VMware with virtualization. Certainly, we want to have the broadest portfolio from a storage perspective. Certainly, we want to have the most open platform as anybody. And certainly, when we talk about virtualizing our storage platforms, we're proud of the fact that it not only virtualizes all the IBM storage systems in the marketplace, but also everybody's system. So we have virtualization capabilities across 300 of both IBM and non-IBM storage systems around the world. Very critical in this space, obviously, to have an open and collaborative way. When we talk about our software-defined capabilities, you really have to understand why data is exploding and how it's exploding. And certainly the dynamics around mobile and social and cloud is really driving data growth, but most of that data is happening in the unstructured space. So data in the unstructured space is growing tremendously. It takes a variety of different approaches to be able to capture and ingest these large databases, these large amounts of data sets that are today when people are trying to do things like real-time analytics, inline analytics, which is their nirvana of what we're trying to do from a data storage standpoint. So, the only point here about this is integration by design is not an afterthought. It's a forethought. You know, IBM's spent a lot of time in the enterprise computing space. We're known about designing, building, and managing, you know, systems at scale. And certainly, you don't drive to an open approach. You don't drive to a approach where you can integrate across all these platforms after the fact. It's a forethought. You design up front, so you'll see, you know, all the different, you know, VMware products and all the IBM products here together. We really take a unique approach, which is to drive this integration by design up front. There's a couple sessions that we have really later this week on this exact point about integration by design. I won't get into it too much right now, but it's about having this as a forethought up front and not doing it as an afterthought after the fact. So I just wanted to give a little bit of a perspective of flash systems, and maybe I'm not sure if all of you are sort of where you operate across the IT infrastructure, but from a data storage standpoint, flash is the hottest thing happening right now in the data storage marketplace. Everybody's doing flash, right? And there are different approaches to flash. Most people today talk about a unique approach, which is you know, what a handful of people are doing right now, which is taking custom NAND flash chips from, you know, suppliers and doing something unique with that, which is quite frankly what allows IBM to do what it's done in this Project Capstone case to achieve some pretty unbelievable results in collaboration with HP and in collaboration with VMware. So, you know, I pass out a lot of business cards at these conferences. This is my business card, but on the back side of it is NAND flash chips. And what's unique about this is there's about 1,000 of these NAND flash chips that go into the IBM FlashSystem V840. Now, why do I make the point to mention that? Because if you go out there and you look through the Solution Center and you talk about flash technology, most people talk about an SSD, a solid-state drive design. You guys have all seen solid-state drives, I'm sure. They look like 2.5-inch drives. They have the exact same form factor of an HDD hard disk drive because most people design their systems for hard disk drives, spinning disk systems, if you will, and then they try to put some software layer on top of it to sort of say, this is 50x faster than spinning disk, right? So what probably less than a handful of people are doing in the industry right now is actually doing the hard work to roll up their sleeves and drive some innovation at an engineering level to take the NAND flash chips directly from their suppliers and build these very unique hardware-defined, custom, you know, optimize everything in the data path to really drive some of these phenomenal results. And quite frankly, that's why we're able to achieve some of these really impressive results. So everybody is comparing, you know, I have a flash product and my flash product is 50x faster than disk. It's about having a flash product that's about, you know, 5-10x faster than everybody else's flash in the marketplace right now. At the core of this technology, because we offer a family of products, at the core of this technology of our FlashSystem V9000 and our FlashSystem 900, we talk about this FlashCore design. And this FlashCore design is really what separates, you know, IBM and IBM's thinking around designing these systems for these highly scalable enterprise systems. Certainly, you know, we have an approach from a scalability standpoint. You have to be able to scale up, you have to be able to scale out, and you have to do everything in between. So when you scale, it's not about saying, I can have one of those, you can buy a small, medium, large scale-out system. It's about having a seamless, non-disruptive way to scale up all your environments to meet your capacity. And that's exactly what we did in this Project Capstone, is have a very highly scalable system. At the core of this FlashCore technology, it's really about three things. It's about taking the NAND flash chips, and it's about doing three unique things with that. One is about a hardware accelerated I/O path. So it's about optimizing everything in that I/O path from the fiber channel port in the back of the storage array right onto the flash chip on the system to say, how do you optimize everything in that data path to make it go extremely fast? Second thing is we build it based off of a technology we call the micro latency module. And if you haven't seen one of these things, you should really stop by the booth that we have outside in the Solution Center to get a sort of a first-hand look at that. But the IBM micro latency module is not an SSD. You can see right away it's very different from a 2.5-inch form factor design. It's a very unique custom design that allows, you know, flash storage technologies to run at microsecond speeds. So while everybody else in the industry who's taken an approach, which is to, you know, carve a path around an SSD solid-state drive design, we're taking, you know, a truly unique approach. Less than a handful of people out there in the marketplace that are truly driving, you know, microsecond speeds. So It's probably been, if you're like me, a long time since you've taken your engineering class. I'll sort of break down what microsecond means from a business standpoint. When you compare, a millisecond to a microsecond, what's the difference? Well, if you compare, a second, 1 microsecond to a second, it's like comparing 1 second to 11.5 days. So a microsecond versus a millisecond, when most people who are building flash systems based off SSD type designs are talking about maybe getting sub-millisecond or getting close to some number under a millisecond, which is 100 microseconds. Running at speeds of 100 microseconds is a 10x improvement. It's an order of magnitude improvement in how we're really able to drive some of the truly capable results that we did with Project Capstone. And of course, last but not least, it's about advanced flash management. Everybody thinks flash is about going really, really fast. It's about having a need for data speed, so to speak. But it's more than that. It's about being able to do unique type of approaches for how we do a variable stripe RAID, how we do over provisioning, how we do everything like from garbage collection. These are all things that we do to extend the endurance level of flash and extend how we do data protection in the flash system. So, it's really important that you run fast with these systems, but it's also really important that you never lose client's data. The worst thing that can happen, Randy, you know this, lose client's data, right?
Yep.
That's a bad thing.
Never good when that phone call comes.
Okay, so look, there's multiple use cases for the flash technology today in the marketplace. I'm not going to talk about every single one. I am going to mention the fact that, the one we highlighted in red is really the one that we sort of rolled up our sleeves and collaboratively worked with HP and with VMware and really said, how do we drive, the really hard stuff, the large data sets, drive it with really fast, big I/O requirements, low latency requirements. I talked about the fact where most people are talking about things operating at sub-millisecond. Millisecond is 1,000 microseconds. So it's about running at speeds that are as fast as 90 microseconds. And of course, it's driving, IOPS per second over a million. So it comes in a 2U, very slim, highly dense form factor, highly energy efficient. This is actually the one of the only products, the IBM FlashSystem product, that's Energy Star rating. So the same rating that you see on your on your refrigerator, on your washer and dryer, the same, U.S. agency that does Energy Star, they have Energy Star rated the IBM FlashSystem appliance as well. It runs extremely low on power, but it's yet extremely fast, extremely powerful from a flash system performance standpoint. And a lot of clients still come up and ask us about, flash, and they talk to others about, flash systems and when's the right time to jump into it sort of with both feet. And they talk about, have we solved the issues of endurance? Have we solved the issues on reliability? Have we solved the issues on, support? And most people get into a very, very technical discussion about how they've solved those challenges, how they've overcome those challenges. We've made it very simple. We came out with the best guarantees in the industry. Flash inherently has so many programmable erase cycles, which means it wears out over time. You can only read and write your flash memory chips so many times. They want to know how long will it last and for what workloads will it last for. We've made it real simple. If it wears out for any reason, no matter what the application is, as long as it's under our service and support agreement, we'll replace it free of charge for up to 7 years. That's pretty amazing, right? People don't ask questions anymore about endurance levels when they say IBM's going to back it up with a full 7-year warranty, a full 7-year guarantee. Of course, all backed by 24/7 service and support in 120 different languages around the world. All kind of helps it make to be a sort of a highly reliable and extremely robust system. So with that, I am going to turn this back to you, Mark, I believe, and let you bring up Todd.
All right. Actually, we'll hand it to Don.
Thanks, guys. So on August 1st, I got a note from Bruce Herndon, who runs performance engineering, August 1st, just a few weeks ago. And he let me in on exactly what this project was about. He explained to me that we have a Superdome X and IBM FlashSystem, and that one of our top performance engineers, Todd Muirhead, was working diligently on the project to actually get lots of results. So I got all excited, and I called up Todd, and I said, Todd, this is incredible. This is what we've been waiting for years. We have now really 100% virtualization. We have IBM, we have HP. We can put them all on stage together. What do you think? And Todd just paused and said, cool. Well, let me tell you what's cool. It's the work that Todd has done here with all of this. And without further ado, I want to introduce you to Todd Muirhead, who's going to talk to you about the architecture and the test results.
Thanks, everybody. So that was actually my first reaction to this whole thing. So whenever Bruce called me up and first said, hey, I got this really cool idea. That is cool. So I'm gonna talk about it in detail as we go through the slides. Hopefully we'll have a good time looking at these results and get into as much of the technical detail as we can. This is my bio. Okay. So we've been talking about this, each of the different companies we go through, but there's three main parts. vSphere 6, which was released early this year, allows us to go up to 128 vCPUs per VM. Which is twice what we could do before in the previous version. The HP Superdome X, biggest, coolest server I've ever gotten to work with. 16 sockets, 240 cores, which is 480 threads, right? So you've got hyper-threading. These are Intel Xeon processors with the hyper-threading. We've got 480 threads. And then the IBM FlashSystem. We configured it 20 terabytes of extremely fast, low latency storage. The IBM FlashSystem, so when they told me, oh, we're going to get the storage system, we're going to get the loaner in a week. And I was like, I don't know. I mean, we're going to have to really, everything's going to have to go just right for this to work out. IBM was able to get us the loaner within a week. And then whenever I moved, I had a couple of VMs ready to go, so I moved them over and started testing. The storage performance was great the whole time. So I never had to go in and tweak and dork around with a bunch of knobs to get my storage set up to give me really great performance. The storage performance was good in all of the tests. It was really cool. So you can see here, this is a screenshot from vSphere 6 with the 480 threads circled.
Nice.
I think it's cool. All right. So this is a fairly simple diagram, but the test bed isn't that complicated. You've got this one really cool server in the middle, and then we have the storage system on the back end. And then we used a 4-socket server as the load driver system, connected over 10 gig Ethernet. So this is like where I live a lot of the time with ESX top. And so when you have 480 threads, this is what it looks like. And it's really cool. So I had people come into my office. I'm like, hey, you got to see this, man. This is 480 threads, this Superdome system. It's really cool. So this is actually from the testing. I don't know if you can see this, but there's 4 VMs down at the bottom running. I don't think it's under load at this point, but anyway. Yeah, so ESX top is kind of performance engineer nerdville, but I use it a lot. Okay, so vSphere vCPU maximums. So the kind of the world of monster VMs, I think officially started in about 2011 when we came out with the 16 vCPU VMs. So I went back, I had to look up the dates and when all this happened and what releases and stuff. So 2011, 32 vCPU VMs were possible. So in the testing that I did, I was able to run 16 of those on a single server all at the same time under full load. And then in 2012, we doubled it. Maximum CPU size is now 64 vCPUs. And I was able to run 8 of those on this system. And then 2015, like we talked about, vSphere 6, up to 128 vCPUs. So 120 vCPUs. So I'm actually not running the exact amount. I'm off by a couple of vCPUs because of the way the math works out with 480 threads, right? So 120 times 4 works out nice and clean. But it's essentially maximum size VM in each case. Another point here, so early this year, I did some testing on a 4-socket server. We were able to go up to 120 vCPUs on a single VM. And at the time, I thought, man, this is like as big as it gets. So we really blew that out of the water. So the configuration, like I said, we varied the number of vCPUs in the tests. Everything else was kept the same for simplicity's sake. We're going to scale up and down. I have to create VMs and clone them and all this stuff. It really makes things go a lot faster when you only have got about a week and a half, 2 weeks to do all these tests, to keep it all as much the same as possible. So we had 256 gig of RAM. There was 2 VMX 3 NICs in each one, and we use PV-SCSI disk adapters. Interesting point here, no pinning. So no pinning was used in the final results. I tried pinning. So pinning is one of these things where you can say, we can go in and instruct specifically, tell the hypervisor to run this vCPU on this physical CPU, and you can actually dictate all that out. And sometimes in benchmarking situations, pinning can help. You can get a little extra performance out. But in this case, pinning actually hurt us. Performance was worse with pinning. So I actually was quite a bit worse. So whenever I disabled the pinning and allowed the hypervisor to make the decisions about where it wanted to run and schedule the vCPUs for each of the VMs, performance was much better. And then, so just to point out again, so each of the VM and CPU combinations that I tested were designed to max out the server, use all 480 threads. And then we compared each one of those configurations against a single VM running with the same configuration. So we have a 1 versus 4 in the 120 vCPU case. Right. So the software. So a lot of this is pretty standard, I think. Red Hat Enterprise Linux 6.5. We use the latest version of Oracle 12c. And then DVD Store 3. So this is my baby, so to speak. So myself and Dave Jaffe open sourced the DVD Store as a workload, a database workload, about 10 years ago. And over that time, we've tweaked it and updated it several times, but we have never done a really big update on it. And this year, I've been working on updating a big revision. There's actually changes to the workload. There's new queries, new tables, all kinds of stuff. And the Oracle version is done. And this is the first time we're publishing results with the new version of DVD Store 3. So that's cool. And one of the reasons why that's important is that DVD Store 3 is a much heavier workload than DVD Store 2 was in the past. So that allows us to run these really high vCPU VMs up to saturation in a much easier way than we would have with the older workload. One of the really cool things that we do is, instead of just doing simple queries, we have some complex queries that they do return the intelligent review. So you ask you're on a store and you go online and you say, I want to know about the reviews for this movie with Kevin Costner, right? So what we do is we return the 10 reviews that are rated by other users as the most helpful reviews. So it's not just a simple like go get and come back. It's a go do some analysis, figure out, and then come back. It's got several joins and it's kind of scary looking when you look at it. But the point is that it's not just simple queries. It's a complex workload. And that was added on top of the normal DVD Store 2 workload that we have, which is just a transactional-based workload with purchases and stuff. OK, so that workload was run at increasing levels. And so we continue to add the number of threads that are driving this load until we find what the maximum point of throughput is. That point of throughput also happens to be, which is the goal, when the CPUs are saturated, or very close to saturation. We were in the 95 to 98% range in all the test cases. Okay. So that was the point where we picked the high point for each of the different tests. So in the case of 120 vCPUs, well, in all the cases, we have all 480 threads fully loaded, under stress. This is a real test. It's not like we just kind of loaded up a little bit of it. No, we use the whole thing. So this is the first result. We're going to start with the 30 vCPUs and work our way up. So in this case, one VM to 16 VMs achieved 14.3x performance. So perfect performance gain in this case would have been 16x. But we achieved almost that, 89% of linear, which is really good. Once again, the system's under heavy load, and we're using all of it. The storage, so this is the first stats I'm talking specifically about the storage. In this case, it averaged about 13,000 IOPS during the test. There's some peaks and stuff in there, but the average is about 13K. But the important thing was that the response time stayed extremely low. It's 0.3 milliseconds, which was plenty. And the whole objective was to have our storage perform at such a high level that we could saturate our CPUs. And we're not pushing this storage by any means to what it's possible of. So we do go up as we go up in the different tests to higher IOPS levels. But as you'll see, the millisecond, the response time latency stays extremely low. So here we are with the 60 vCPU VMs. So again, this would have been almost the maximum size VM in 5.5, just less than a year ago, the maximum size that was possible. The scalability of this one isn't quite as good as what we saw in the other two tests, but this does happen to be the test that performs the highest. So the absolute value of all 8 of the VMs running at the same time is actually higher than the other 2 combinations. I have some theories about just exactly why. We're gonna go into it in the white paper. But it was really interesting to see that you see a little bit of difference as you look at the different configurations, but still excellent scalability. And then finally, this is the results from running all 4 of the 120 vCPU VMs at the same time. We were to achieve a little over 90% scalability, and we're all the way up to 20,000 IOPS at this point, average, still at a 0.3 millisecond response time. And here I point out that, so at the beginning of the test, before your database gets everything cached up, you're going to see a peak in IOPS, and we would see it peak up to about 50,000 IOPS. And again, you handle that with no problem whatsoever. So what's next? There is a session that I'm giving with David Morris this Thursday on Monster VM database performance. And we're going to talk in a little bit more detail about the Project Capstone results. So we have a little bit more time. And then there's a white paper, which I've mentioned, I think, a couple times, which I'm going to start writing as soon as I get home. So we started, like we said, we started in August, and then I was still testing last week on Wednesday. So I was still gathering results and putting slides together and stuff like that. So I have all the results, but I haven't had any chance to really write anything. There was a blog that I posted today with basically the results that we talked about today. So there's some out there if you go to the Vroom blog on VMware.com. But anyway, so like I said, we're going to get to it as soon as we can get it done. I'm saying probably about a month, but we'll see. And then follow-on projects. So it was a really successful project. I think it was really cool. I think lots of people did. So the plan is to do more. And one of the things that came up at first is we had this awesome storage array. We wanted to have something that was a little more I/O intensive. This workload turns out to not be that I/O intensive. So we're looking at doing some database workloads that would be on that range, try to push the storage. And then one of the things we've also done some work with is with SAP, SAP's HANA in-memory database. And this, the server that we're using can go up to 12 terabytes of memory, has 12 terabytes of memory, which would be an ideal candidate to do some HANA work on as well. And with that, Don's going to come back up, and we're going to go to Q&A.
So I'll just stay here. Anybody got any questions? Come up to the mics. Yeah, go ahead, sir.
For Todd, you mentioned that the storage wasn't really fully maxed out. I mean, how much further do you think it could have gone?
So I talked with the IBM guys. They loaned us the storage, and we were talking about it. And I feel pretty confident we could hit 100K pretty easily without doing much. The IBM guys have told me that they've done tests and they've gone much higher than that. So that's one of the things we're going to do in the next test is to put something together and put some real numbers behind that, because I don't really know. All I can say for sure is that it comfortably handled all the work that we threw at it really easily.
Anybody else? Okay. I want to thank again all the vice presidents and Todd from IBM, HP, and VMware for joining us to introduce Project Capstone. You're going to see a lot more data and a lot more publicity around this as the next few months come along. And as I said, we really are at a point right now where we can confidently state that 100% of applications and databases that exist, like Pat Gelsinger had asked us to do a few years ago, we're really at a point where we can confidently state that they can all be virtualized. So thank you, everyone.